This is the part 2 of the video of atmospheric pressure for class 8 physics. So you can go to page number 51. If the video is not so clear, then you can read it out from the book and you can listen to me. So standard value of atmospheric pressure, I said in the last video, is around 1 lakh Newton per meter square. But as you all know, there is another unit for pressure, which is Pascal. So at sea level on the earth's surface, the atmospheric pressure is around 76 centimeter or 760 millimeter of mercury column, which is equal to 1 atmosphere, or which is 1.013 into 10 to the power 5 Pascal. So they are generally giving us three different kinds of unit. One which is 76 centimeter and or 760 millimeter of mercury column, which is equal to 1 atmosphere. Here 1 atmosphere. Okay, I think you are not able to see, I just underline it. So it is 76 centimeter or 760 millimeter or 1 atmosphere and Pascal. So they are talking about mercury column, etc. This is because mercury is used in a barometer, right? And the height of the mercury in that barometer, because of atmospheric pressure at the surface of the earth, shows around 76 centimeter or 760 millimeter. Which we are studying in class 9. The more about it we'll study in class 9. So the other unit is ATM, okay, atmosphere, and the other unit which you all know is the SI unit, Pascal, whose values are given. So 76 centimeter of mercury or 760 millimeter of mercury or 1 atmosphere or 1.013 10 to the power 5 pascals, they are all same. Okay, note the atmospheric pressure decreases with increasing altitude. That is, as we go higher above the earth's surface, the air pressure decreases. Because as okay, let me explain this. So like last time, I am trying to draw earth, this time pink, last time it was black. So suppose we consider this surface, let me use another color here, violet. Okay, here suppose we consider this surface here and consider this height here, right? This height will exert pressure, this air column will exert pressure on this surface. So but suppose we consider a big mountain or a big plateau or a big building, then the air above it decreases, right, because of its height. So this building is getting less pressure, less atmospheric pressure compared to this object here. So as we go higher from the surface of the earth, what happens to the atmospheric pressure? It decreases because the air column above it also decreases. Okay, so the atmospheric pressure decreases with increasing altitude. That is, as we go higher above the earth surface, the air pressure also decreases. Okay, some examples in daily life to show the existence of atmospheric pressure. Okay, there are 10 examples, right? And for each example I'll be sending you a link of YouTube video. If possible I'll be sending all 10 links, okay, very short videos. So I'll be going through this topic faster, and then through those YouTube videos for single topic, it will make your concept more clear. Okay, some of the examples in our daily life showing the effect of air pressure are given below. When a drink is sucked with a straw, the air of the straw goes into the lungs, and thus the air pressure in the straw decreases. The atmospheric pressure acting on the drink exerts force on the drink to move up into the straw and then into the mouth. Okay, so what happens is, so when you are trying to suck some soft drink or juice, what happens is first air in the tube will go in your lungs. So what happens, the pressure drops, at this point the pressure drops. and because of this atmospheric pressure which is acting on the surface of the soft drink, what happens is the pressure pushes the liquid down through the tube and helps it to go in your mouth, right? Next thing, the next thing is the next thing is number 2. When we blow air in balloon, it bulges because of the pressure exerted by the air filled in it. Okay, because the air is exerting pressure on the balloon, right? I've sent you one video also regarding balloons. Okay, I hope you have watched them. I think, I don't know how many videos I sent, but I think you have watched those videos. The next one is number 3. I will be not sending any video for point number 2. Number 3, it is due to atmospheric pressure that ink gets filled into a fountain pen. Okay, I hope you know what a fountain pen is. I think when you started writing with the ink pen, you must have used the fountain pen. You need to fill ink in that. Nowadays we get a cartridge. Okay, so what really happens here is like it's like suppose there are two kinds of fountain pen. Okay, suppose we take a sorry suppose we are taking a fountain pen, right? Okay, so we're taking a fountain pen, and you have noticed that there is a part of a pen where we have to fill the ink, okay, provided by a piston, something like this. So when you pull this out, okay, the ink gets in. So the initial position of this piston will be somewhere around, somewhere like this. Okay, the piston will be here. So when you pull this thing out, right, when you pull this thing piston out, so what will happen is, as the piston is going up, right, you have dipped your nib of the pen in the ink. What happens, there will be a drop of pressure here as this goes up. Okay, I don't have eraser here. As this green thing goes up, there will be more vacant place. There will be more vacant place as the green thing goes up. There will be more vacant place here. As the vacant place is getting increased, the pressure here drops because there is no air. So the ink will try to go in the nib and try to fill in that um, place. They try to fill that place, right? And because it is just because of the atmospheric pressure, right? Okay, I hope you have understood this. I'll be sending a video on this. Number 4, water is drawn up from a well by water pump because of atmospheric pressure. Okay, water pump. uh, I hope you know water pump is, right? So I'll be sending a video on this. Number 4, point number 4. Number 5, the syringe gets filled with the liquid with when its plunger is pulled up due to the atmospheric pressure acting on the liquid. Okay, so it's same as the fountain pen. Okay, the liquid gets filled in, the medicine gets filled in the syringe with the help of atmospheric pressure. Number 6, rubber suckers are used as hooks in the kitchen and bathrooms. They remain pressed against the wall due to the atmospheric pressure from outside. For this I'll be sending you another link, okay, for the video, which I cannot explain here right now. Okay, I have to make a video on this separately. Number 7, it's difficult to take out oil from a sealed tin if one hole is made in it, because if only one hole is made in it, the air will enter through that hole, and when you try to take the liquid out of that hole, the air will try to keep the liquid inside, right? But if another hole is also made, I'll be sending a video on this also. uh, but if another hole is made, what will happen is, uh, through one hole the air enters, and through the other hole the liquid can come out. If you tilt the can, from one hole the liquid will come out the other hole, provided there's a gap between two holes. Okay, right? Next thing, like your rubber suckers. Okay, lizards have those kind of rubber suckers at in their leg. Okay, so lizards are able to move on the wall and stay whenever they desire or wherever they desire. This is because their feet behaves like a suction pads, so they remain pressed against the wall due to the atmospheric pressure. Now point number 9, the astronauts and mountaineers have to wear special type of suits, because as we go up the pressure decreases, so our blood pressure will increase then, because it has less atmospheric pressure to balance. So they have to wear a special type of suits to protect themselves from adverse effect of low pressure prevailing at the greater heights. Low atmospheric pressure, okay, low atmospheric pressure and high blood pressure. Number 10, nose bleeding often occurs at high altitudes. The reason is that atmospheric pressure is low at high altitudes, but the pressure inside the human body does not change. Thus, the excess pressure inside the body compared to the atmospheric pressure causes nose bleeding. Okay, so this ends the chapter. I shall do the numerical problems in the next video. Okay, thank you.